Good morning, my wonderful humans and cow dogs, or what is it? No, I can't remember. Clara, was it Clara? So what I'm talking about here is the whole moof thing. But first, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, moof, the dog cow. Right, yeah, sorry, Mad. Could have been a bit scary. Razors. Yeah, okay. I will take care of that eventually. It all started after I had my wisdom teeth out like a week and a bit ago, and I had a bit of swelling around my jaw and just I couldn't be bothered shaving, so I didn't, and then I just didn't start again. So this is what, about 12 days or so worth of laziness. So, good morning, everybody. I hope you're all doing really well. Oh, David S., hello from Northern Kentucky. People from all over the place. This seems like it's way too on topic for this live stream, but Pablo said, what about a cluster of apps with MQTT embedded working in HA mode? I assume in this context, HA means high availability, not home automation. Yeah, okay. So that is a rather big topic. Let's not get into that right now. Okay, so you're talking about APs, not apps, like as in access points. So each access point with a node of an MQTT cluster. Yeah, well, this is really on topic. Pablo, thanks for bringing this up. One of the, you're having really good thoughts here. I like the way this is going. One of the side benefits of designing our own access point, and this is kind of jumping straight into the topic, but hey, let's do it, is that it gives us flexibility to do things with it that you don't normally get to do with access points. So access points, they can be characterized in a few different ways, or there are a few different major types of it. And I'm trying to think of how to summarize this. There are a few different approaches. One of the approaches is an access point that is like an all-in-one thing. It's also a DHCP server, and it can be a router, and the classic open source way to do that is with something like OpenWRT, and then you can run other things on it as well. And another approach is to have dedicated access points. So access points that are really just access points. They don't try to do any routing, they don't do anything else. And that is the Unify approach, and many other companies as well. So what they have is access points, and this is what I have in my house now. Access points that are just access points. They don't do anything else. You can't run anything on them. They simply act as radios that pass through the Ethernet connection that you've plugged into them, and support VLANs and all of those sorts of things, but they need to be integrated as part of a bigger overall system. So Pablo, bringing up that idea about using access points as distributed MQTT nodes for like a high availability cluster, that is one of the clever things that can be done if you are running access points that have more of like a full stack computer that you can do things in. So maybe we will get to that. But for today, Scott says, lack of a beard is a sign of weakness anyhow. Okay. All right. Jordan says, I'm going on 12 years of laziness on my face. Peter Lawler is calling out Tassie Bob, Sudo, make me a coffee. Yeah, I wish I had a Tassie Bob here that I could say, Sudo, make me a coffee. I've already had a coffee this morning. I don't need another one. And it sounds like I'm awake. At least I'm pretending to be an awake person, I think, fairly effectively. Okay. Let's chase a squirrel. And now the thing is that Steve is not looking over my shoulder today. He is not here. He is on duty as the night watch squirrel at the super lab. I left him there yesterday. I was there yesterday doing a bunch of things, so he is still there. He's probably watching the rats running around on the floor because there is quite a rat problem. I put down some bait yesterday and hopefully we'll manage to get rid of rats, but right now we have rats. So Dodgy asked, is it bad itchy? No, I think it's just past the itchy stage. So beards kind of get annoying after a few days when they're long enough to be scratchy but not long enough to kind of started becoming softer, and it's a little bit past that. Incognito, Steve is a rat test. Yes. Anyway, getting back onto the subject that is off subject, which is coffee. I had a funny thing happen yesterday. So I was at the factory yesterday doing some work, and for those of you who saw the live stream probably about a month ago now, it was a couple of live streams ago when in fact it was the first live stream I did from the factory, and partway through Alan walked in. So Alan has a factory behind mine and Lachlan's, and he builds rally cars. You probably, if you watched the stream, you would remember that. So this was the stream where Cable Tie came in at the end as well, and we had a chat about tools and things. So yesterday I was at the factory, and Alan came in again and was having a chat to me, and at some point, so the thing is that I only know of him as someone that builds rally cars, and in his factory he's got, I don't know, like 7 cars or something. And so he came in and said, do you like chocolate? And I said, I sure do. And he said, I'll get you some. And just turned around and walked out the door again. And I was thinking, what? Like now? So I followed him out, and we went back up to his factory, and in he's got shelves in his factory that were stacked, like full-size blocks of chocolate, like this, the large size ones. And they were like in blocks of 10 of those, and there was just stacks and stacks of them on the shelves. And he said, you like Kit Kat? Here, have some Kit Kats. Do you like caramel, whatever? Here, have this. And he was giving me like this big armload of chocolate. And it turns out that he is a process engineer and works at Nestle. So the reason I bring this up is I've talked before about the things that are around around the factory. I've got the coffee bean grinding factory right next door. There's the industrial bakery down the end of the street. There is Stewart's sawmill directly over the road, so we get the nice smell of all the cut timber. All of these cool things. Now it turns out that Alan has like the world's biggest stash of chocolate in the factory directly behind me. So yeah, I ended up with a very big pile of chocolate yesterday, which I then regrettably left at the factory. Incognito, I hope the coffee bean grinders are upwind. Well, yeah, they are directly next door, so it almost doesn't matter which way the wind is blowing. If they are grinding, I am smelling that coffee, the coffee beans being ground. It's fantastic. Yeah. Oh, Scott says, give it another week, then you'll hate shaving it off. Yes. Oh, okay, so Ender Wigan, Ender, that's a cool handle. You should take a look at the 7621 module. You could also use the postcard chip. I will look at that. In fact, just so I don't forget it, I'm going to open a browser that you won't be able to see, and I'm going to stick that in it so that when the time comes, I don't forget your comment, because I'm still in tangent mode. 7621 module. I'm not familiar with that. What is that? Gigabit Ethernet router module test kit from Highlink. Ah, interesting. Okay. That definitely looks interesting. So it's a MediaTek based router module, only module or with board. That's kind of not quite the approach I want to take, but I am sticking it up here because we can come back to that. Thank you for that. Thank you for that pointer. That's really interesting. That's right. So, who was it? Scott was saying, "Give it another week, you'll hate shaving it off." Yeah, I've grown beards before. I've had it significantly longer than this in the past, and yeah, I just when I want to get rid of it, it's not that bad because I just use the clippers and clip it all off so that it ends up pretty short, and then switch to a razor and take it back to the skin, and it's all fine. So, oh, Aaron's here. Awesome. Thanks for coming along, Aaron. I hope you're doing really well. Oh, the Celtic Beast asked, is it Alan who does the circle workout at the front of the Super Lab? No, I don't think it is. Alan's, he's a rev head, but he's not that kind of rev head. He's more of a going fast sideways on dirt rev head than someone that would just rip up all his expensive tires and leave the rubber on the road. Okay, so yeah, so Aaron says, seems like years ago we talked about this IoT access point project. I think we mentioned maybe using a CM4, but I noticed in your render is a Pi 2.0, which would be interesting. What about Zigbee and Matter? Yes, okay. Aaron, thanks for getting me back on topic. Oh, and outside the box, not at the track today, so you're missing the smell of the high octane fuel as well. Now, okay, let's jump up to here. So, Ender pointed us at this little module here, which looks like basically it's a complete router on a PCB, and it's also available as just that module without the... So what you can see down here is in the bottom right, looks like there are 5 RJ45 sockets. So the one on the bottom right is probably like a WAN port, and then 4 LAN ports. You can see the magnetics behind it. And what have we got over there? There's a footprint for like a memory card, and there's an I/O header here. There's power down in the bottom left and USB, and up in the top right is this module, which is this MediaTek based module. And if I switch to only module, which is it's about 60 bucks. It's a little like a SOM, system on module arrangement with the MediaTek processor and some other stuff. So it looks like with this, what you could do is build a complete router. Yeah, Gigabit Ethernet router module test kit. That's the same thing from a different vendor. So let's have a look at, well, these photos don't really show us all that much. Let's click to embiggen. All right, so this is the embiggenated version, and this is basically no, I assume this doesn't have any Wi-Fi. There's no antenna connection, there's nothing else like that on it. But what we could probably do is use this module as the starting point. But what I'm going to do is a very brief recap and show you what I've done so far. Oh, Mitchell says, check the conditions for the OpenWRT version on the AliExpress page. We'll most likely have to rebuild for the latest version of OpenWRT for security, etc. So Ender says, I think you should have a switch and Wi-Fi on the AP. Right, now, I will give you a brief recap of where I've got to so that we can move forward from there. Well, what am I doing? What am I doing? I am looking for that button right there. So, as I talked about on the last live stream, which is kind of what, that whole discussion is what has prompted me to revisit this exercise. I'm going to be sliding off camera here. Bye. So, the first version I did, in fact, do I have one here? I don't know. My first experiments with this were basically a Raspberry Pi 3. Well, this is not the same thing, but inside there is a Raspberry Pi 3B Plus. This one was because I was messing around with Z-Wave. And so what I did was I simply got a Raspberry Pi 3B Plus, no modifications. I powered it. I was powering it using a power over Ethernet hat that I designed, but that's neither here nor there. It could be powered in any way. Ugh. Cat hair or something on it. And the magic was just in the software, in the host APD configuration that allowed it to do personal pre-shared keys. I talked about that a little bit in the past. What I want to get onto today is messing around with the hardware side of things. And so you can build a wireless access point with nothing but a Raspberry Pi 3B Plus. So, you know, that's what I use, but of course most Raspberry Pi models will do it as long as they've got Wi-Fi. You can build your own access point. And that's what I did. So then I decided I wanted to take it a little bit further. And this is a RockPi, trying to remember, RockPi S, I think is the model. It's a kind of Raspberry Pi work-alike. This particular part of the header I think is basically the same as the start of the Raspberry Pi header. Like the top of the Raspberry Pi header has got the two 5-volt connections on here, it's got a 3.3 volt connection there, it's got a 3.3 down here. So these pins are basically the same as the top part of a normal Raspberry Pi header. And this little 4-pin header in here, this is bringing out the power over Ethernet connections from the RJ45 socket. And it's got a connection on here for an external antenna, so you can get decent Wi-Fi performance out of it. So there's a whole lot going for these little things. This is based on a Rock chip, hence the name RockPi. And so it's a Rock chip CPU, and it's got USB-C. So there's a whole lot to like about this. It's a really nice little board, but I had problems with getting the host APD stuff working properly on this board. And also, there is an issue because the Ethernet socket on here needs to be exposed in the enclosure. So it's kind of zoomed in a bit too much for you to see the whole thing, but this is the enclosure that I'm using. I got this from SZOMK, and there's a cover that goes over it. Because it is so massively zoomed in, it's a little bit hard to get the perspective, but you can see it's kind of reminiscent of something like a Unify access point. It's that disk sort of thing, and you know, Cisco and other places make access points. This same sort of form factor. It's like a smoke detector concept. The idea is that you've got a bracket that fits typically onto the roof, and you would drill a hole through and you'd bring an Ethernet cable through here, and then the cable can pass through one of these slots and wrap around, so that you take your access point, you shove it up against the bracket, you clip it into place, the Ethernet cable will be coming down through the ceiling, going through this slot, wraps around, and then you plug it into the Ethernet socket. So this is like it's like a UFO that is attached to the ceiling, like an oversized smoke detector sort of idea. Anyway, these enclosures come from SZOMK, and I can't remember how much they are, but they're not a lot. For what you get, for having an enclosure that is specifically for wireless access points, I'd have to look it up, but my vague recollection is that they're in the region of like $17. for the enclosure, maybe as much as 20 bucks, you know, with shipping fully landed in my hand sort of thing. It's something in that region. So to get an enclosure that is actually pretty decent, it's not a bad price. And I did 3D print one of those pie enclosures a couple of years ago when I was starting with this, and the pie enclosure was huge. It was much bigger than this. Like that, it was like a dome that curved all the way across, like a section out of a sphere, and it was just enormous. This is much smaller than that one. So anyway, this is the direction I ended up going in. I thought, I'm just explaining my my thought process here. So I started with a Raspberry Pi, and that worked, but it was a Pi. I wanted something that was in a form factor that I could mount properly, that would support power over Ethernet and all those sorts of good things. So and also Raspberry Pis became hard to find, so I ended up doing this experiment with the Rock Pi S. Now, the reason that I can't just mount this down here and have it stick out here, a couple of reasons. Actually, maybe that could go under there. Yeah, thinking about this more now. What I could have done is hung this board underneath a carrier board so that the socket would end up in about the same place as that. That would kind of work. And that is still a possibility. But what I ended up doing is, which way around does that go? That way. Okay, I'll put this back in place. What I ended up doing, are there any screws holding this in? No, it's just sitting there. Okay. Is this rather dodgy arrangement. So what I've got here is this carrier board acts as an interposer. So there is an Ethernet socket here. This is the externally exposed one where you plug in your cable. And then the data pairs from that come along through here. And if we look under the board, you can see that there is a second Ethernet socket. And this is a pass-through connection. So what I was doing was I had, I don't know where it is right now, somewhere around, I had a super short Ethernet cable, basically a patch cable that plugs in there. It comes around the PCB in a loop, comes right around and plugs into there. And so what happens is that once you plug in Ethernet here, the data connection comes through here, it travels along the PCB, out this socket, through the patch cable and into here. Which sounds kind of overly complicated, and it kind of is. But one of the things that allows is intercepting some of those pins. So on pins here, we have breakouts that come from here, and you can see there are some diodes there. So what this is doing is picking up, I've got to try to remember, I think it's 4, 5, and 7 and 8, something like that. So it's picking up the pairs that are not used for 100 base T, and it feeds them across to this voltage regulator. So what this gives us is multiple options for power over Ethernet. You can use a power over Ethernet regulator module in here, like for 802.3 AF, so full 48 volts PoE, with a module that mounts through the PCB here. I made that slot just for clearance purposes. Or if you put jumpers on here, power from here goes into this voltage regulator, that's an automotive rated 5 volt voltage regulator, and that then feeds into the Rock Pi S, which regulates it to 3.3. And then you can see along here we've got some WS2812 RGB LEDs, because I wanted to be able to do things like make it glow different colors to show adoption status and whatever. I just thought it would make it cool to make it glow different colors. And what else have we got on there? I think I stuck a temperature sensor or something on it because I wanted to be able to just measure the temperature at the access point. Where is that? I think that's on the board under the rock chip module. Yeah, there it is. You can see the little, what is that? MCP 9808, I think it is. I2C temperature sensor. And you can see some patch wires on here. Now, for the most part, this kind of works. The part that doesn't work is being a Wi-Fi access point. Well, that's not quite true. It does work as a Wi-Fi access point, but I had trouble with the configuration of the routing and the host APD setup in here. So I thought that what I would do, oh, and the reason that this loops around, and you can see there are some little holes in here, my plan was to 3D print a couple of mounting brackets so that this antenna would be held approximately there. It would end up being mounted in clips that would hold it in that position, and then when the cover goes on, it would be basically just underneath the cover. So it's getting there. My phone just buzzed and I'm trying to work out why. Okay, I'm going to ignore that. Topo, what am I missing in the chat? Because I couldn't read it while I was over there waving that thing around. Blue, yep. Oh, Dodgy says, yeah, it even has the blue light look of the Unify. Yeah, the cover. And in fact, you can get this particular ring. So it's, I can probably pop it out. This is a plastic ring. Here we go. That drops into this. And this is available in different colors. So when you order the enclosure, you can specify what color you want. Like whether you want blue or green or red or whatever. I think I stuffed up because my intention was actually to get this just as clear, because I didn't want a specific color visible unless the LEDs were making that color. I wanted the case to glow, and there are no light pipes other than the little spigots that hold this thing on. There are no light pipes or anything to carry light through to this. Now you can see there are moldings here for putting in, what size are they? 3mm at least, maybe 5mm LEDs could fit into there. So what you can do is have LEDs sticking up off the PCB such that when the enclosure is put on, the cover is put on, the LEDs sit inside these little tubes, and then you'd be able to see them glowing through here. So you could have status LEDs visible on there. I haven't made use of that though. That's just part of the molding of the enclosure. But what I wanted was to have this just clear, and I could just print a replacement. So I could use some translucent PETG or something, and I could print a new version of of this ring. Oh, it doesn't want to come out now. Yeah, I could print a new version of that, so that, because the thing is that when it's got this strong blue color, it's kind of drawing too much attention to itself. When this is mounted up on the ceiling, I don't want it to be that obvious. It should, it's not a, what am I trying to say? It's not a design feature. Things like access points, they should be functional and kind of invisible. So when this is mounted on the ceiling, I don't really want it to be drawing attention to itself. And having this strong blue ring around it is kind of just drawing too much attention. I'd rather just have it all plain color. Unless the LEDs are specifically illuminating it to show something, like having it flashing to be in adoption mode or some error that's occurring or whatever. The rest of the time I just want it to be invisible. Cough coming up. Hang on, I gotta mute myself. Hopefully you couldn't hear that. I saw the VU meters jump way into the red. Yeah. So Aaron said, so change to a Pi, such as a CM4 or a Pi 2.0 for better silicon support and XZB matter connectivity and support and jobs. God, good, yes. That is basically the plan. Now, let's give ourselves some eagle action. It's going to take a little while to boot, but luckily this is one of the nice things now about the fact that I'm not running OBS on my main computer. I'm just capturing its screen. It means that I can, hang on, where is the camera? There. It means that I can run Eagle and Fusion 360 and those sorts of things and not worry about it. So I've just got to bring this up onto this tiny little screen that is the one that's being shared, and schematic. So what we're looking at here is I started with this board here. So this board needs some modifications. First, I screwed up the mechanicals a little bit. It's a bit hard to see on that camera, but I slightly offset the position of these screw holes. I didn't get them in quite the right place. And then you can see that they are quite large here. And that's because I had to drill them out bigger to make them fit over the mounting stakes. So you see that peg there and that peg there, they're the same size. That hole there and that hole there should be the same size. So this hole was originally this size, but it was in the wrong place. So I just drilled it out to make it fit. And so I need to make some minor mechanical improvements, like fixing the positions of those. And there is a spot in here for a button. It needs to move to the right by maybe 0.5 millimeter. The power jack is in the correct place. That worked out well. And these are in the right place, which worked out well. But I'm going to get back to this particular Ethernet socket because this is a really critical issue. It's something that I'm trying to solve right now. So this board was my starting point. And then, based on what Aaron has just been saying, what I did, leave that. You can see here there is the there's the RockPi S headers. Oh no, that's where it was. I've since replaced it. So what I did on this was delete. In fact, let's do this. Raspberry Pi 0W headers. What I did was I just deleted in here the RockPi S headers, and I replaced it with headers for a Raspberry Zero. And we've got the Ethernet pass-through. I deleted the other socket, and so what we've got is this in a state of being massively hacked around. It's in a transition between two different things. And then what I did was on this second sheet, this whole section here that you can see, which is the Ethernet interface with the PoE support coming into the WIZnet W5500, this is taken directly from the Rack32. And all I did was copy that big chunk of the schematic and dump it in here. And one thing that I've changed is this Ethernet socket. And as I said a moment ago, that's a critical thing, so we'll get back to that. Then we've got the PoE regulator part of it here. I think where did that come from? I can't remember if I changed that over. The Ethernet status LEDs, they come from the Rack32. So the plan here, the very general, vague, poorly thought out, cunning plan, is to replace the RockPi S with a Raspberry Pi 0W because I know the software environment on the Pi. I have a working configuration running on a Pi 3B Plus. I know I can make that work. So I'm just trying to eliminate things that are maybe beyond my control or ability or whatever to end up with a system that is what I think is a workable starting point. It may not be optimized, it may not be the best thing for for like the ultimate system, but we need to get a system working before we can begin optimizing it. So yes, a CM4. Stephen W said, I agree, a CM4 would be really suited for something like this. So Aaron says, not the W, use the Pi 2 0. It's basically a Raspberry 3 with 1 gig of memory, but then it doesn't have Wi-Fi. Surely? So a Pi 2 0, yeah, but we want the Wi-Fi capability. Now, I'm just going to go and grab something that is currently off screen. It does have Wi-Fi, but, okay. Oh, it's the 2, not the 0W. The Raspberry Pi 2 0. Hang on, I've got to look around. I may even be just using the flat out wrong terminology here. Let's see what I've got, because I got I bought a little while ago. I got this. Let's see what it is. What did I order? I don't even know. Raspberry Pi 0. No, it is a 0W. It seems. Oops, I better not expose. I was about to throw the packing slip. No, it is a 2. Raspberry Pi 02 W with GPIO card. That was what I ordered. So, hang on. I may simply be calling it the wrong thing, which would not surprise me in the slightest. Little Bird sent me, thanks Maddie, I hope you're well too. Little Bird sent me Raspberry Pi 0W GPIO header. But let's see what is in the bag. What did I actually get? It is a Pi 02, Raspberry Pi 02. Well, seems like I didn't stuff up that badly then. Maybe I did get the right thing after all. And let's just come back over here and go Raspberry Pi 02. There. All I had to do was change one character, and I think Aaron will be happy now. Yes. So I've been calling it the wrong thing. It is actually a Raspberry Pi 02, not a 0W that I have here to go on that board. Anyway, it's one of those things where I probably did actually think about this at the time. When did I order this? Oh, it wasn't that long ago. January 15th, 2022. So it's only a few months ago. That was when I ordered this 02. And at the time, I would have looked at the range of Raspberry Pi models and checked out all the options and which one would best suit my needs, and hopefully I made the smart choice at the time, which turns out to be the Raspberry Pi 02. That was the decision I made back on January 15 when I placed that order. Now the CM4. Okay, so yes, the way I like to approach these sorts of projects is iteration, successive, a different way of putting it, successive approximation. I know that I am not going to get the design perfect the first time around. And how to explain this? in trying to make the most optimized design possible on the first iteration, often ends up it ends up being a design that can be hard to rework or adjust to suit, you know, changing needs. So with this sort of project, it's kind of an illustration of my approach. What I do is I typically start with something like a board that is a known. I want to eliminate as many unknowns as possible to start with, to get to a basic working system. It doesn't have to be the cheapest, it doesn't have to be the smallest, it doesn't have to be the most performant or the lowest power. It just has to work. Got to make something that works first. And so something like a CM4. So for those of you playing along at home who haven't seen this, let me go back to here and explain what this is all about. So Raspberry, got to put my hands on the keyboard in the right place. Raspberry Pi CM4, so Compute Module 4. The Compute Module 4 is, let's look at Core Electronics' page about it. So it's this little board that goes onto a header, like a very, very fine-pitched header. And it comes in all these different variations, so you can see whether it's got wireless or not, whether it's got on like a PCB antenna and an optional external antenna, how much RAM, how much storage, whether it's available in bulk or not, and like there are big restrictions on ability to buy modules at the moment. So on Raspberry Pi. So what this thing does, let's find another picture of it. Let's go Raspberry Pi CM4 versus 0, and let's look at some pictures. It's just a different form factor and variations in options of the configurations and things. And so the earliest compute module went into a slot that was kind of like a memory slot like this. But the current ones, so what you can see here, is that in a good place on the screen? Oh, look, it's Jeff Geeling's site. So Jeff always does cool stuff. Raspberry Pi Compute Module 4 review. Okay, so that is the compute module, and this is a very good comparison. This is a handy photo. It's exactly what I was looking for. The normal full-size Raspberry Pi. So in this case, it's a Pi 4 Model B. Which I've been using the 3B Plus. It looks approximately the same apart from some port differences and things. Then the Pi 0W, which is this one here, or the Pi 02, it once again looks approximately the same as this. It's in that form factor. And you can see the Compute Module 4 here, which is a little shorter than the 0 and a little wider. And it doesn't have these through-hole headers on it. Instead, it has a connector on the bottom. Let's see if we can see a picture of the bottom of it somewhere. That's a dev board thing that it goes into. Here we go. So this is the connector. It's a very fine pitch connector. So what you can do is put this socket on your carrier board with some mechanical mounting holes, and then the Compute Module 4 plugs in on top of it. And then, actually, if I go back to that dev board, that's probably a good way of understanding. No, they don't really, it doesn't even show it. Oh yeah, there it is. Okay, so this. Let's have a better look at this one. What you can see here is a carrier board, and it's got a couple of HDMI breakouts, it's got Ethernet and USB, etc. There's an SSD plugged in, and here you've got the Compute Module 4 sitting on the carrier board. So what's shown in this photo could be kind of similar conceptually to what I am wanting to do with building this access point. Okay, so then what I would do is a version of this that I wouldn't have HDMI on it. I would have a connection like an antenna connection or something. It would have the power over Ethernet support stuff in here. It could be a variation of this. And that is absolutely a valid way to go with this design. But this is my iteration process. What I had in mind is that I very likely, or could possibly, end up with a compute module 4 on this board instead of a Pi 02. But the Pi 02 has an onboard SD card, which makes it quite easy to deal with. You can do, so the CM4 has, I think it has eMMC memory, I can't remember specifically, so that it doesn't really need the SD card. But the point is, the 02 is very close to the Raspberry Pi 3B Plus that I've already been using, and that I have successfully have an image on an SD card that works. I have an access point that I can run like that. And what this allows me to do is switch to this slightly smaller form factor and be one more step in the process towards an optimized final thing. So the Pi 02 does not have onboard Ethernet. You can see there's no network socket on it. There is support for Ethernet in the chipset, but then it needs, I think, external magnetics and basic stuff off the board, which can be put on the carrier. But once again, I want to stick with things I know, and I know the WIZnet chips. So right, where was I? That's right. I am going to go, you can't see this, but I will get there. Just got to open my project folder for this particular thing, IoT AP, and notes. Alright, my notes file. Just before I bring this up, is there anything in here that I should not expose? I just want to make sure I don't have passwords or anything in here, which is quite possible because I've got chunks of config file written into here. Change to, oh yes, there is something there that I should not expose. Ubuntu, yeah, there's a lot of historical stuff in this file. I'm just going to show you the top part. Where can I go? Down to, yeah, okay, there. I think that's safe. If I bring my notes up on screen here, and can I zoom? Yes, I can. Let's get some extreme zoomage so that you have at least a little chance of being able to read this. So this is my notes file from this particular project, and you can see, well, I don't think it's like that anymore. What I did was I found a few things like this. So if I go to here, oh come on, I pasted that. So Brian Dory did this post about modifying the 02 to use the footprint that's on here for an external antenna connection. And what you can do is disable the connection to the onboard PCB antenna, and then you bridge across here, and you can see there's all these big solder blobs there, and then add the SMA connector, and no, it's not SMA, what am I talking about? UFL connector, So that's just showing adding the UFL connector onto the PCB, and then you run an external antenna, and voila, you get better Wi-Fi performance. So the 02 does support an external antenna, and it even has the footprint on the PCB for it. It just doesn't come with that connection in place. So that's what I am planning to do, is just add that in there. Other things, there is this post, which is adding a Ethernet to the, this was for the CM3, but you know, similar things apply for other models. And there is an overlay already available for the WIZnet W5500. Oh, you probably can't read any of this. Oh, not that way. I want zoom in, zoom in, zoom in. So other people have already done the hard work of supporting the WIZnet chipset on the Pi on the Compute Module 3. So that is very encouraging. And here we've got information about how to do it. So it's got the commands for loading the overlay and settings here. There's the overlay link, and use GPIO 0 for interrupt, setting that as the int pin. Oh, and there's temperature sensor setup stuff there, and WS2812B setup stuff here. I'm not going to go too much further because just down below here is where I start revealing some PSKs and keys and things. So yes, I know a PSK is a key, but I mean a different type of key. Anyway, so these are my notes about things that other people have done for adding improved Wi-Fi performance and LAN on Raspberry Pis that don't have the onboard Ethernet. Oh, where am I up to? Okay, nearly an hour in, and I have not done any design work at all. Yeah, so Aaron says, I believe the Pi Zero supports Ethernet hats, meaning you could use the exposed headers to add Ethernet from your board. Yeah. And the other part of this is the support for PoE. So, you're right, Aaron. I would probably, that is one of the things where, this is coming back to this process again. Working with what I know and what I have available to make something that works, and then iterating on that to optimize it. What I know works is the Raspberry Pi platform from a software point of view. I have that working. I know the WIZnet W5500 from an Ethernet point of view and power over Ethernet. I have that working on the Rack 32 and other boards as well. I've used that one a few times. And so what I want to do is stick with those knowns and build a working system, and then in future it can be optimized by doing things like replacing the Pi 02 with a compute module, or replacing the WIZnet W5500 with just some external magnetics and using the onboard Ethernet support of the Pi. But each of those things are sort of future iterations. Yeah. Oh, David T says, WIZnet might be super slow. By memory it is SPI. Yes, it is SPI. So it probably won't be the fastest thing in the world. Now, where are we? We are here. So, where I got to with this is just some major hacking around, copying and pasting things out of other projects to get it in here. I've done the footprint for the Pi 02. and you can see that I screwed up the footprint because we do not have 2 Kipo pins. One of those should be Kopi, or Miso and Mosi, depending on which terminology you prefer to use. I screwed that up in the footprint and I should fix that. I'm not actually using those pins, I just noticed it when I dropped the footprint on the, like I dropped the symbol in the schematic and I thought, hang on, I shouldn't have 2 the same like that. What I'm going to be using is SPI, as David mentioned. So I've got Kipo, Kopi and serial clock coming out here. I need chip select. Now where is chip select? Now this is where it comes back to my notes. I need to, ooh, Tony. Designed a LoRaWAN gateway using a Pi 0, added Ethernet and PoE, works really well, low power, only 2 watts, works outdoor without overheating. Nice. Good work, Tony. I'd be very interested in that because this actually raises an interesting thing. Who was it? Someone earlier just talked about someone was just asking me, yeah, it was Peter, that's right. Peter Lawler was asking me about Matter, and I'm not going to get into that right now, but it's an illustration of an issue, which is flexibility for future compatibility. And one of the things that I have in mind with this, and this comes into Tony's comments about the about LoRaWAN as well. What I would really like these access points to do, and also right early on in the chat, I'm really sorry, but I can't remember the name of the person that said this, talking about making the access points distributed MQTT nodes for redundancy. What I have in mind is that if you have several access points around your house, which is like a typical scenario, each one of those access points could, if it's running something like a Pi architecture as its main processor, could also be running an MQTT broker as a, so we could have like redundant MQTT brokers. And this is where my friend Andy's service discovery stuff comes in. That's a whole extra topic. We can do really, really cool stuff with that. We could have service registrars running on these nodes and have failover between the registrars. So we can add support for things like LoRaWAN. So your Wi-Fi access point could be a Wi-Fi access point, a LoRaWAN gateway. It could be a like a Bluetooth type node, which means it could do things like detecting Bluetooth devices and presence detection of Bluetooth devices, like using people's phones to figure out if they are in the house. It could be an environmental sensor. Potentially, it could be a motion detector for presence detection, like if we wanted a radar type thing. Now, I know this is feature creep to the max. I'm talking about all the different things that can be added into this, and it could turn into a bigger than Ben-Hur sort of project, and I don't really want that. But I do want the flexibility to be able to add these things if that becomes useful. And basing it on something like a Pi as the main processor gives us a whole lot of flexibility to introduce that, because it's not like a really optimized platform that is really just going to run as an access point. It means that we can do all sorts of fun things. Oh yeah, and Tim said Zigbee router. Yeah, so, and David said 433 gateway. Exactly, this is the sort of thinking. So you could have a couple of these devices, like in a typical house, you could have like 2 of these devices, maybe 3, and you've got, we could have support for Z-Wave and whatever. It could be modular. There could be a header in there where you put in like an equivalent of a shield for your access point to add support for different radios or whatever. Yes. Oh, Aaron has a TI libs to support ZB Matter. Oh, yeah, Home Assistant Yellow Hub. Yeah. And Austin said OXRS support. Yes, that goes without saying. Quick support. Yes. So many of these things are possible when you have a capable, flexible, well-known platform as the heart of the system. And then we can add peripherals and things to suit different needs. And by making all of this open source, if someone wants to do a different spin of the carrier board that happens to have different peripherals, fantastic. That's really cool. Anyway, enough ranting, not enough routing. So, what was I thinking? That's right. I was going to talk about the interrupt pin on the W5500. So there's a power supply thing. There is a whole lot of doubling up at the moment. What you can see here is, as I mentioned before, I've just been copying and pasting stuff into here. And so what you can see down in this power supply region in the schematic here is the power supply on that existing board. The one I've just been showing you with the Rock Pi S, this is what's on it. You can see that there's the DP1435 power over Ethernet module. This is the same as in the Rack 32, so it supports 48 volt power over Ethernet. And there is diode isolation for just an external power jack. There is the input coming here from power over Ethernet, and that is, so you can do like the DIY power over Ethernet coming in here, and in all cases they feed into the 5 volt regulator that then feeds across to the Rock Pi S. So if we and this is the Ethernet pass-through, which is upside down. It's under the bottom of the PCB. So then over here, I just pasted in the Rack 32's Ethernet setup with its Ethernet socket here. And so what we're doing is pulling out the power over Ethernet, because this particular socket has the built-in magnetics. It's got little bridge rectifiers in there, and it brings out the power here to give us power over Ethernet V- and V+. And then we can use that for our own purposes. So, oh, and there's the WISNet. So this is a proven design from the Rack 32 and other places. All right, so some things to do. You can see here, we've got things like the reset pin, and there's the interrupt pin that we may not need. There are the SPI pins, so we need chip select, and we need the serial clock, and we need the SPI interface. And these nets are not connected at the moment. Austin said, is the tab the right way with the Ethernet? That is a very, very good question. And also, raising the issue with the 7805 for the power supply, we've been trying to trace down power supplies versus noise issues. Yeah, so I know, Austin, you have a favored switch mode regulator that you use on your boards, which seems to work very well. So what I should investigate is switching the Rack 32 over to using a switch mode regulator instead of that that automotive 7805, which in theory I think is good for up to about 2 amps, but it could be a problem. And it does get warm, so it's really not ideal. But the issue with the tabs, yes. Now, this is an area where the power of the crowd LM2596. Cool, thanks Austin. I actually do have some of those. When I saw that you were using them, or do I? I think I do. When I saw that you were using them on your boards, and they seem like a really good thing, and you mentioned them before as well in chat, I think, or on Discord or somewhere you've talked about them, and I think I ordered some, and I should have a few of them here. I don't know if I have the inductors that go with them, but I do vaguely recall looking into getting the parts for that so that I can switch over to using that instead of the linear regulator. Now, okay, so this is the power of the crowd, the power of the open source. Finding a suitable Ethernet socket. Let me explain the problem. If we look at, if we look at the bottom of this enclosure, what you can see is the PCB sits on these mounting stakes, and it is kind of flush with the top of the hole through the enclosure. Now, you can see there's the Ethernet socket there, and in this case, the tab is towards the bottom. Unfortunately, the focus on this camera is just a fraction too high at the moment. But if I adjust it, it's going to mess everything up. So I'm going to leave it slightly out of focus. So you can see that the LEDs are down here, the tab is on this side. And if it was the other way around, so if the tab was up the top here, you wouldn't be able to get in there to remove the Ethernet cable. If I plugged a cable in there, the tab would be hard up against this part of the enclosure and you wouldn't get it out again. It really needs the tab on this side so that you can use your thumb or whatever and click it and pull the Ethernet cable out from this side. Because if it's up there, you will never get that cable back out again. Now, if I take this PCB out of the enclosure, and then I'll turn it over so that it's on the side that the thing is mounted, what you can see is that the tab is at the top. It is away from the PCB. Now, by way of contrast, most common Ethernet connectors are the other way around. Well, I don't know statistically which is most common. I'm kind of going for a wander away from the camera here. What am I looking for? I was looking for an example of, where's a rack 32? I should have one around here somewhere. Or even a, or any board that I've made with Ethernet, because I've used the same hand run Ethernet jack on pretty much every Ethernet board I've ever done, and I can't believe that I'm wandering around and I can't even see a single one. Oh, here we go. This box up here will have some. Does indeed. So, this Ether 10 has a hand run. It's an HR, what is it? HR 11179C or something? I can't remember the specific part number. But this Ethernet jack is the opposite way around. They're kind of like twins, but backwards. One of them has the tab at the bottom, one of them has the tab at the top. And this one is the one that's on the rack 32 and lots and lots of other projects. Now, this particular jack works brilliantly with the WIZnet chips, with PoE, and with the different PoE regulator modules and things that I've used over the years. So I want the equivalent of this, but in the mirror image. And like this. This one, you can see there's a difference here. This one is really short. Mechanically, this is what I want, but it does not have the built-in stuff necessary for supporting it doesn't have the magnetics and things. I could use externals, but I'd rather not. So the ideal, you can see that it's shorter because it just doesn't have as much stuff in it. What I want is that, but upside down. That is what I'm trying to find. Now, Gavin says tabs always face down because gravity. Yep. The LAN, Alston says, also been using a newer SP32 that uses LAN 8720 Ethernet chip. The library for it gives some cool functions, including knowing link speed and IPv6 support. Well, that could be useful. So maybe I should be using something like a LAN 8720 instead of a WISNet chip. I just clicked on the link from Austin, so please don't rickroll me. No, it looks like we are at Mouser, and this could be the solution, and this is, hang on. Oh, this is the funniest thing. So, Austin just linked me to this. Look at this part number. Look at this part number. Oh, hang on, you can't see it. I'm on the wrong camera. Okay, so Austin linked me to this page with this part. Now, I think what might have just happened is you have just given me a huge amount of reassurance that I'm doing the right thing. Look at this. Joink. Look at this part number. ARJM 11D7114ABEW2. This is the RJ45 socket that I have put on here as a placeholder. And I'm pretty sure it's the same. Let's have a look. Library, open library manager. Where are we? Connectors. And gotta get this back up in here. So RJ45 by 1 PoE with LEDs, and I've got two different versions of that. One is the ARJM 11D7114ABEW2, which looks awfully like this one. So Austin, looks like we have come to the exact same conclusion when faced with the same problem. I am very reassured now that I'm that I am on the right track. And James, just to answer your question, that's kind of a yes. So all right, I can breathe a sigh of relief. What I was worried about was that this was not a direct equivalent functionally for the WISNet chip that I've been using. It was the closest one I could find in terms of pinouts, no, not pinout, in terms of the pins that it exposes. Now the pinout is kind of a mirror, just because the socket goes in the other way around. And so this right here is that chip. Is that particular socket. So if we go to the if we go to the PCB view here, take that across. Yeah, you can see that there's some stuff doubled up. So this socket down here, this is the one mounted on the bottom of the PCB, which I had not taken away because I wanted that as a record of the physical location, because the physical location seems good, and I hadn't actually deleted that out of the schematic yet. So that's going to be replaced by this one. So this one right here is cable tie. Oh, we can all relax now. You're here. So this one, and as it turns out, is the exact same part that Austin has been using. Is I should have just asked you, Austin. I spent ages yesterday and the day before going through Ethernet sockets, looking for one that had all the features that I wanted with the orientation that I wanted. Ages going through LCSC and DigiKey and just general Googling, and eventually concluded that this particular one is the one that I want. And I am glad to know that I was not mistaken. Now, oh, is that inverted? Did I flip it? Yes, I did. I mirrored it. Okay, so what we can do is, what is the x coordinate on this one? It's minus 13. And that's because I do not, the origin of this board is actually like where? Here. It's center bottom, but that's just because of the way I was trying to work out the geometry. So if I go back into here, back up to here, and go, what do I want? GPIO2 B6, why do I want that? GPIO2? Oh, that's from the rock chip, which is no longer there. But if I, let's just do it. Let's do this. Doink. And back to here, or back to there, and then I want that to be at minus 13 millimeters, and then I will stick it where about there, somewhere like that. Anyway, routing doesn't matter at the moment, that's all going to get fixed up later. I just want to get the major components into the correct place. And you can see there are actually two of these DP1435 regulator modules. You can see there's this one sitting over here and this one sitting over here, and that's because this one is the residual one from my old power setup. So you can see there's that one there. So where am I going with this? Oh, cool. Austin sent you CAD files on Discord PM that confirm chain Ethernet jack pin out. Fantastic. Thanks, Austin. I will have a look at that and make sure that my the footprint that I made for it is the same. I ended up creating using a really dodgy 3D model. In fact, let's get some Fusion happening. This will take a while to launch, but I'm going to open Fusion 360, and just for the fun of it, I pushed across the in progress broken board to Fusion, and I've got into the habit of doing this really early on. So when I'm working on boards like this, I find that it is extremely helpful to have the 3D representation in my brain, even as I'm working on the schematic, because the three different elements, the schematic, the PCB layout, and the 3D model, are all very closely and intrinsically tied together. And I found that once I incorporated 3D into my design process, and incorporate it early, it's made a huge difference to how I go about designing things. So Fusion 360 has almost finished opening, and so I've got this really dodgy 3D model for that particular socket, which I didn't create. I grabbed it from somewhere, and it was only available as an IGES file. And it isn't even for the same socket, it's just for an upside down Ethernet socket. And parts of the structure are missing. So where am I going? Where am I going? Oh, that's right, I was looking for Superhouse projects and the IoT AP. And then I'm going to switch this up to the other screen so you can see it. Opening now. Come on, you can open. All right, here we go. Dragging up here, and no. Weird render thing. What I was trying to do was drag it like that, so it'll maximize. All right, so this is the board. that was pushed before I deleted this socket, obviously. And you can see that it is, at this stage, just a lightly modified version of the board that I was showing you a moment ago, the actual real board. And all I had done at this point was delete the headers for the RockPi S and delete a bunch of traces and remove some things, and then dropped in the the Pi 02, dropped in, so this is the 3D model I've got for that Ethernet socket, and you can see that part of the structure is strange, it's weird anyway. And there is the other, these are the parts associated with the WISNet interface. So there's the W5500, there are a couple of resistor arrays, this is the PoE bypass jumpers, and then just the passives and things that support that Ethernet interface. Dave T, oh, thanks for coming on. I know there are other things to do. Good to see you here today. So my next steps with this project are to continue with hacking around on the schematic to unify the power supply. So things to do. Let's in fact, let's actually do this. I'm going to say unify, unify power supply designs, maybe replace linear reg with, Austin was saying, where is it, the LM2596. I'm going to put a question mark against that one. Move diodes near bottom jack, relocate PoE module to under PCB. Yeah, that's still valid. I want to, what else was I going to do? There is so much to do on this. Maybe investigate, I spell good. Investigate the LAN 8720, another Austin suggestion. And what else? Oh, let's just leave that and go back to thinking about this. So what am I doing? I've got to bring, of course, the other thing I've got to do is I've got to, come on, I've got to allocate Ethernet SPI pins, inc chip select and int. Definitely chip select. I'm not sure if I need the interrupt pin. And what else? Aaron says, just a thought before you start routing. Okay, yeah. Might be worth taking the header pins out of the back of the Pi 0 to avoid sandwiching the chip between the two PCBs. The Pi 02 does run warm. Yeah, okay, so the issue with that, what I might end up doing, in fact what I think I will end up doing, is putting the Pi 02 into pin headers into a socket so that it can be removed. And Austin says no int but yes on RST and chip select. Yep, cool. So the sorry, brain fart. I got distracted reading other things. Another thing I'll get back to, which is a bit differential pairs. So I've totally lost my train of thought. What was I thinking about? Austin, that's right, we were talking about the CM4 getting hot. So the issue is I still want access to the the header for the antenna, which is right about there. It's on the top of the PCB. So the antenna, if we go back to, do I still have it open? Adding a LAN compute module, wherever it is. Raspberry, okay. Raspberry Pi 02 add UFL antenna. Maybe that'll find it. Should be in my history anyway. Oh yeah, there it is. Brian Dory, that's right. So it was Brian Dory's blog post that we were just looking at. So yeah, as you can see in this photo, the location for the socket is on this side. So what I could do is, oh, hang on. Yeah, okay, no. Austin, you were right. It was a good point to point out, but I think I actually already have it oriented that way. So what I've got is, my plan is, yes, I will have the pins come out of the back of the Pi 0 so that it goes onto the carrier board in this direction. And what this will do is have the CPU on the top of the PCB where it has the maximum free air. So it won't be between the two PCBs. And that is, but my reasoning for doing that was actually not for that heat. It was because I need to get to that antenna socket which goes on the top of the PCB. Right. So, yeah, Aaron, you're absolutely right. Sorry, I thought it was Austin that had made that comment, but no, it was Aaron. So, yes, it will go on the board in this orientation with the chip on the top and the access to the antenna connector on the top as well. So, I also don't need this big hole in the middle of the PCB anymore. Let's get rid of that. That. Let's just do this. Delete group. Boink. Gone. Okay. I really wish the 3D connection space mouse would work in this view, but it doesn't. It'd be nice to be able to zoom in and out and pan around with it, but no space mouse support. It only works in Fusion 360. So, where are we at? Okay, just for the fun of it, I'm just going to push to Fusion. Push, yes, do it. While I am looking back at the chat again. Yeah, and easy access to SD card. Yes, you're right, Aaron. No, now, while that is pushing to Fusion 360, Stephen said, were you using differential pair impedance control traces for the Ethernet on the PCB, or you took the YOLO approach? I totally YOLO'd it. I just, I didn't do length matching or impedance control or whatever. So the Pi, okay, so Gavin says, so the Pi is on the bottom of the board. How big a range are you after? Does it really need an external antenna? It probably doesn't need it, but it helps. And if we switch back to Brian Dory's blog post about this very topic, he did some testing. So it's kind of basically rough testing, like what you can achieve outside of a proper lab environment with all of the gear. What he did was some testing where he just used it without the external antenna and checked what networks he could see and what signal strength he was getting and that sort of thing, and then did the same thing with the external antenna, and you can see that the signal strength has gone up reasonably significantly. So it does make quite a difference when using the external antenna. Yes, it would work. And on the on my playing around with my first iterations of this access point, just on the 3B plus, I don't have an external antenna. I am literally running a Raspberry Pi with Ethernet plugged in and power, and that's it. And it works. It's not the greatest range, but it does work as an access point. So what you could do is just use this with the onboard antenna, but by putting this UFL connector on it and then running an external antenna, which will of course depend on the antenna and other factors, you can get an improvement in performance. So not essential, but it just makes it better. Now, where were we? That's right. I was just pushing this thing to Fusion 360. Where's Eagle? Yes, it's been pushed. Back to Fusion 360 and update. So we should see this Ethernet jack jump down to under here, and this will disappear, and that hole will disappear. So what else do I need to do? I need to get my to-do list in order so that I can work through it. So Gavin asked, could the PCB form part of the antenna? Not the antenna of the carrier board, because there needs to be a way to link it. And tuning antennas is a job that I'm not willing to undertake. I have seen the pain that people like Sion have gone through with doing this. Hang on, I've got a cough again, just a second. That's better. Which reminds me that I have not grabbed a drink this whole time, because before this started I grabbed the SodaStream bottle and I made up some, what is it, dry ginger, and chucked it in the fridge. Sion says, come on, it's easy, no magic or wizardry at all. I'm sure. And no need for expensive test equipment, you know, like VNAs and that sort of stuff. No, nobody needs that. Yes, and as Stephen says, there's also the wireless approvals that are needed. Yeah. So, here we are. Oh, go away. So here we are. I need to make some minor adjustments. So I need to fix the position of these two holes, as I pointed out earlier. These need to move, I think, to the right and down like a millimeter or something. And then got the Ethernet socket under there. So yes, I need to order some of these Ethernet sockets. I haven't actually ordered them yet. I think I've got them in my shopping cart on DigiKey or no, Mouser or somewhere, but I haven't ordered any yet. And part of it was I was going to ask for feedback on what this socket should be. Thanks to Austin, I now know that I'm on the right track. So back to back to reality. Back to this. Back to this. What have I got here? Do I need any of this? No, I don't think I do. That's residual. So I need to figure out what... Oh no, I don't need to control those. Yeah, okay. Sorry, thinking out loud here. The reason that these nets are here is that they are the LEDs on the Ethernet connection, and I was controlling them directly out of the Rock Pi S using GPIOs. But I don't need to do that, because those LEDs on the new version are going to be controlled by the Ethernet chip. They will be controlled right here. Those LEDs, activity LED, and activity LED comes off. Where does it come off? It should come off. There we go. Activity LED. There. heck, why wasn't that highlighting when I double click that? So activity LED there, links to activity LED there. Yes. Yes, okay. So full duplex LED, speed LED, link LED, and they go to both these status LEDs that are directly on the PCB and also to these two LEDs that are in the network socket. So I don't need to drive those using GPIOs off the Pi like I was with the Rock Pi S. Because the thing is that on the Rock Pi S, so I don't even know if it's worth talking about this. The reason I had to do that, which was dodgy, was because I was not directly using the Rock Pi S's Ethernet socket exposed on the edge of the board. I had another Ethernet socket with pass-through, and the signals on the Rock Pi S that illuminate those two LEDs are not available on the header. So I had to double up that using GPIOs. But I don't need to do that nasty hacky thing anymore because it's taken care of by the WISNet chip. Now, what else? Let's get back to this to-do list. To do. Unify the power supply designs. Let's do a little bit of ordering on this as well. Come on, I want that. I want that. And let's put that in there. Replace linear reg with LM2596. Allocate Ethernet SPI pins. Investigate LAN. Okay. The reason I'm reordering this is, oops, if I replace this with a LAN 8720 instead of using the WISNet chip, then allocating, that's a dependency basically. Allocating the Ethernet SPI pins depends on the chipset. Move diodes near bottom jack and route traces from there. This was just, these are notes from the previous iteration. And relocate PoE module to under PCB, which may still be valid. But move diodes near bottom jack and route traces from there. That is for the isolation. I don't think I need that note anymore because that is all going to be taken care of when the power supply designs are unified. What else do I need to do? Design it. So power supply, let's, I don't know. I'm kind of just screwing around here, not really doing useful things. Which way around do I want this to be? Do I want it to be like that, or do I want it to be like that? I think I want it to be like this, which is going to mean moving. Let's just grab this and shove it out of the way for a while. Move it down here, grab that, stick it. Where is it going to fit nicely? I need access to, which are the screw holes? Now these ones don't, I'm going to get rid of these because these, you see these holes here, these little sets of 4 holes? These are, I'll get rid of that and that for now. These are where I was planning to put in antenna mounts, like 3D printed brackets to mount the antennas. I'm just going to get rid of all of those because they confuse things. So the screw holes are that one and that one. Now this power supply is going to have to be reworked. Let's just move that out of the way for now. Take that, sling it off the board, bring this down here. And I want to locate this in a place where I can get to the mounting holes. I want to be able to get to these screw holes here. I want to be able to get to these mounting holes, and if it's kind of centered, what is that? Oh, that's 0 offset. Yeah, okay, that's dead centered on the PCB. So how about it just lives right about there? That seems like as good a place as any. What this will do is put the socket about here, right there. That's where the antenna socket is going to be. So then it can be a little pigtail cable sticking off somewhere, and then an antenna mounted somewhere over there. So I will need to add holes for mounting brackets for the antenna. But I just want to leave enough space up here. Let's move it up a bit. Up about there. Because then there's still space to put a screw head there. There'll be a screw head there. Mounting holes here, and plenty of space. That looks okay. Let's just temporarily lock that in place. And yeah, I'll get to reworking the power supply. So as usual, my plan for this had been that I would be working through this on the live stream, and I've spent the live stream talking about it instead of actually doing it. So what is the chat talking about? So Austin says, yes, the LAN 8720 does use a fair amount of GPIO, but for something like a wireless access point, it gives you far more coding options. Yeah. Okay, so while this is doing its thing, let's have a quick look at LAN 8720 Raspberry Pi. How to add Ethernet to a Raspberry Pi Pico. Oh, this is one of Alistair's articles. Alistair does cool stuff. I met him a few years ago at, it was in the US at a conference. What was it? OzCon, I think? Would have been at, yeah, it would have been at OzCon. In fact, I met Alistair several times at different OzCons over the years. So he seems like a really cool guy. Now, what am I looking for? Okay. Oh, Sandeep. Sandeep, yes, is well known. Oh, for it says, Alistair said, Sandeep is well known as the author of the Noble and Blino Node.js libraries. No, that's not where I know Sandeep from. I know Sandeep from other. Sandeep did I think a CAN bus library. Yeah, for Arduino. So yeah, I've used some of Sandeep's stuff before. Ethernet Mac in software currently supports RMI-based Ethernet PHY modules like microchip blah. Okay. 8720, yes, blah blah. Wiring things up to the breadboard, so there's a module there. What do I need to do? Okay, so here we have some pinouts. So this is for an RP2040, and that, I believe, is the same GPIOs as on the 0. Someone can correct me on this. My my naive understanding is that the RP2040 is the same chip on the 02. Different form factor though, I believe. So whatever we find here should still apply. So things like the, yeah, so the Raspberry Pi Pico is the tiny little thing with the RP2040 on it. I think, let's just check that. Raspberry Pi 02 specs. What is the CPU on it? Is it processor? Oh no, it's not. It's not an RP2040. Interesting. So maybe it's not the same. Stephen says, everyone here knew going into it that there wouldn't be much doing, more discussing. Yes. Yes, so Xeon, thanks for clarifying that. The RP2040 uses the MCU, 02 uses the Broadcom GPU, yep. So it uses the BCM 2710A1. Alright, so the I/O is going to be different. Let's see. I think I just woke up my voice assistant, which is about to say something because it's confused.
Sorry, I don't know that, but I do have a skill you might like.
Alexa, stop. I should have muted it beforehand. Alright, so what I need to do is find a pinout that is suitable for attaching the LAN 8720 to a Pi 02. Raspberry Pi 02. Let's try this to a Pi 0. Pi 0, how to add wired Ethernet. That's not necessarily including the thing with pluggables. Okay, no, I don't want that. That's a USB thing. Using GPIO pins. Is that with an 8720? No, that's with an ENC 28J60. I don't want to ever use that chip again. I have painful memories of maintaining the library for that for Ethernet. Oh, for Arduino years and years ago. Let's have a look at this one. Aaron's provided a link. Let's see, what is this link? Oh, hang on. Is it the same one I just had open? I think it is. No, where was it? That one, yes. It was the one that I had just opened. So that is, this was from May 2020. So this will be a Pi 0. Oh, and it's is that using the ENC? That's the one that I can't stand. What I want is LAN 8720 with a Raspberry Pi 02. That is exactly what I want. But what do we get? What do we get? ETH board. Oh, maybe this. I wonder if this will give some clues. If this works on the so this is the same module as was shown in that other thing. Integrated 1.2 volt regulator. Yeah. Okay. Yeah. PoE. Let's see what this one is talking about and what they're pairing it up with. So the LAN 8720. What is this connected to? Don't know. Let's see. Let's go back to the original. This is in German, but that's okay. So before I go ESP32, no, that's with the ESP32. I think I clicked on the wrong thing then. We should have. Let's see what this is. Pi boxes. Pi. I think I'm kind of getting off track here a little bit. This is not quite what I'm looking for. What I was just looking for was Gavin, 9-minute warning. Yeah. Oh, Austin, I'm curious. What are you pairing the LAN 8720 with? I'd like to know what board you're connecting it to. It is possible that whatever pins they have selected are the same. So let's have a look at... I'm looking at the wrong thing. Raspberry Pi 0 to LAN 8720. I've already closed that search that I had open earlier. Yeah, this is the one that was open before. Oh, you're using it with an ESP32. Okay, cool. So it's a different thing anyway. So what I need to do is just find out how have they done this. So what have we got? Clock interrupt, wake on LAN, we've got SPI, reset, and what are we connecting it to on the Pi? So we've got GPIO 25, 9, 11, 10 and 18. Let's see, I assume that the SPI ones are going to be straightforward, so that's not a problem. Then there's an interrupt pin, clock and wake on. Okay, clock is not connected. That's interesting. Oh, maybe that's used for something else, because we've got serial clock here for SPI, and then we've got power. I don't think that's a big problem. We can make those connections. Let's, it's going to be a little bit tricky. Hang on, I'm going to pull this down off onto this other monitor. I'm going to massively compress this and then drag it to there, and then let's switch to Eagle. Oh, okay, close that and go to schematic view. Come on, respond. There we go. Oh, I was going to start hooking things up, but I don't have a LAN 8720 on here. All right, so I'm going to need a footprint for a LAN 8720, and that is beyond the scope of the next 4 and a bit minutes. But what we can do is have a quick look at the pins that have been allocated on that page in that blog post, and what I have here. So let's have a look at at this, and drag this across a bit, because what I want to do, I'll minimize that. What I'm trying to get in view is that this list of pins in view at the same time as this, so that I can do a side-by-side comparison. And I'm trying to squash it all onto this little monitor that is being captured for streaming purposes. Okay, so what have we got? Int is going to pin 22, which is GPIO 25. I don't care about the, so GPIO 25, oh 22, it's the same, okay. So let's just run that there. What else have we got? So just going through, we've got GPIO 25, GPIO 9, GPIO 23 is being used. Why is that being used? Okay, that's worthy of investigation. Pin 20, IO 23. Oh, I'm looking at the wrong thing. Pin 23. Yay. I need to look at signal names, not pin numbers. All right, so ignoring the pins. IO 25, yes. IO 9, yes. IO 11, yes. We have IO 10, yes. IO 8 is chip select. Where is 8? It is, oops, not there. It is here. Cool. So let's stick some labels on these and at least start allocating pins. So let's stick some net names on them as well. So IO8, I'm going to call this, I've gone backwards and forwards on this over the years with conventions on how I label nets. My current convention, which has been stable for a while, is to use the pin name of the microcontroller or whatever is the main device with the purpose. So in this case it's IO8, and IO8 is going to be, I could just say CS, but there could be multiple SPI devices, so I'm going to say Ethernet CS. And here we've got IO9, which is being used for TPO. Oops. We've got IO10, which is being used for copy, and we have IO11, which is serial clock. Just call it SCK, not SCLK, doesn't matter. And then IO25, so IO25 up, where is it? IO20, there, IO25 is int. Okay, so this is going to be IO25 underscore ETH underscore int. And it doesn't actually say here, but usually int is inverted logic. So if we put an exclamation mark in there, we get a bar over the name, although that should probably be done at that point. So ETH underscore int is the signal, and it's inverted, so it's got the bar over it, which may or may not be the case. It's not indicated here, but usually things like interrupt pins are active low. So I'll mark that as active low. Then what have we got? Oh, let's just name these. Let's name, what am I doing? I will name IO2 SDA, and also one of the things that I usually do in order to help me keep track, what pin was that? IO3 SCL. In order to keep track of things like unassigned nets or nets that I have named but haven't yet used, is I often put the okay, one little thing here. If I try to rename this, so none of these, if I had named these something the same as an existing net, it would have come up with a message saying, do you want to connect to net blah? But it didn't, so none of these are actually going to do it. One way to check whether you have these nets connected is to select the name tool and select rename, and it will ask you if you want to rename other nets as well, and it's not asking, so I know this net is not connected. But it can be, and also when you run electrical rules check, it'll find all the non-connected nets, so you'll get an error at ERC stage anyway. But what I often do is, just as a reminder to myself, I come into, I grab a no connection symbol and I stick it on each of these. So what this will tell me, if I look at this, if I come back to this project, like after this live stream, I'm not going to continue with this. I'm going to take a break because I need a break. But what will happen is that when I come back to this project, I will see that I've got these nets that are named coming off this chip, and I will see that they are marked as not connected. So that is an indication that something still needs to be done with these. It's incomplete. And then I can get on with setting up the schematic and don't have to rely on the ERC to catch that error later. Yes. Oh yes, so Stephen is right. Yeah, so not for the main SPI pins, as they can be common to multiple chips. Only chip select and int are specific to the Ethernet. That's right. So controller in, peripheral out, and vice versa. They will be shared on the bus with other devices, and then there can be something like a chip select pin for each of the devices that is on that serial bus. What? Oh, Austin said, Stephen W. So Stephen W said something like that. So Stephen said, I don't think you will be able to use the 8720 on the Pi 02. Okay, so maybe I'll have to stick with the SPI. With the WIZnet chip anyway, which is already in the design. Yes, Richard, I am losing my voice. So yeah, that's a good point. I will need to check whether there is support for the 8720 on the Pi. If not, I can just stick with the current design. So what I've got now is the pins allocated on the Raspberry Pi. Now I've got I2C here for onboard sensors and things like the temperature sensor. I've got SPI here for Ethernet. Got the Ethernet interrupt chip there, and interrupt net. And on the other sheet, I've got the WIZnet Ethernet chip. Now what you can see here is these nets have not yet been assigned. Now we've got keep, copy, clock, and chip select. And what I should have done previously was add. Now if I go to rename, the rename tool on this, come on, rename tool. It's not going to ask about renaming other nets because it is the only one. I should have put that little no not connected symbol on there to remind me that this needs to be linked. But what we can do is, let's link them now. Kipo is IO19, so IO9 rather. Come on, why is this not selecting? So IO9, and then I can come down to here and do the same thing on here. And it will now ask me if I want to connect it to the existing net. And I will say yes. And then let's do the same thing on this one. But this one is going to be IO10 copy. Do I want to connect to the existing net? Yes. Now what was my clock pin? Clock pin, it's unfortunate they're on different sheets of the schematic. So my clock pin was IO11 SCK. So clock, come on, IO11 SCK, yes, and chip select. What was the chip select? It is IO8. Let's just be lazy and do this. Chip select, Wiz chip select, and that. Yes, I do want to join it. All right, so now back on here, I can remove these. Oh, come on. Why can't? Why is this being so weird today? So I can remove those not connected symbols. So now we have SPI connected. We don't have the interrupt connected. I'm not sure if we even need that on the WIZnet. We've got WizInt here. I think I will connect it, but I'm going to have to look up the pin outs. So, okay, I'm going to put that on my to-do list actually. Because, let's allocate Ethernet SPI pins. That has kind of been done, but what I want to do is say check check int pin on W5500 with Raspberry. So what I don't know is whether I need to use the interrupt pin, and that's going to mean checking what has been done. I'm going to look at what other people have done with the W5500, but I'm going to call it. I'm not going to keep going with this right now. Oh. So that is an unknown at this point. Do I need the interrupt pin connected on the W5500 to the Raspberry Pi? I don't know. There is an interrupt pin coming out of the W5500 here. I might just leave it with its pull-up resistor and not going anywhere else. Or I might connect it to IO25. We shall see. What else do I need to look at? What else can I look at while I'm here? All right, I'm going to get rid of that because I don't need it right now. It's not turned out to be useful. Maybe what I should do is a little bit, just before I wrap up the live stream, do a little bit of rationalization on the power supply side of things. So what have I got? Power supply. I've got a double dot power supply. I've got 2 of these V-Regs. What do I have on this version of it? I've got power PoE V plus coming in from there. So these nets loop down, comes into here. I've got bypass going to 12 volts, and it doesn't have the DC jack. I'm just thinking through this process, because what I could do is either delete this or delete this, and I don't know which one is better. I think I might keep this. So I've got VA1 and VA2. PoE V plus, VA1 goes to PoE V plus. So what I could do is delete that net. I'm going to rename that one and link it to PoE V plus. And yes, I want to link it. And this one will be PoE V minus. Yes, and link it. So this is not going to work. I've got to change those jumpers. The PoE bypass has to come from there. Okay, so I can ditch some of these diodes, which is nice. Let's get rid of. Oops, no, I don't want to do that. I was wanting to delete. Let's get rid of some of this stuff. Delete, delete, delete. So what's going to end up happening out of all of this is eventually I'm keeping this here just for reference at the moment, but eventually I'm going to delete this regulator and I am going to keep this one. That's kind of the decision I've come to. And I'll probably end up moving this onto the other sheet of the schematic to bring it down here so that all of the stuff that's related is in the same place. So we've got the Ethernet connection here, we've got PoE coming in on here, and I want PoE to go into the voltage regulator part of the project, and I'll put that down on this same sheet. But for now I'm manipulating it on this sheet up here. So yeah, and then later I might replace this linear regulator with the switch mode regulator. Now, where was I? That's right. I want to change the bypass so that I've got PoE plus and minus. What am I doing here? I'm going to get rid of all. Oh, come on. Tool selection is not working properly. I'll get rid of those nets. Don't actually, I'm just going to check, does that net exist anywhere else? No, it doesn't. Okay, so that net will totally go away, and then I can get rid of one of these. And I also want to change, no, I won't do that. I will change that to make it an SS56 shuttry diode. I will delete, what will I do? I'll delete that, and let's just do a bit of moving around. Shove that over there, shove that over there. I probably need a better topology for how I'm laying this all out. This is all going to be kind of ugly. I'm going to rearrange it. All right, that can come down to there. I want to tie that into that net. That can go there, that can go there. And what I don't like about what I'm doing right here is I'm going to have these nets the same. I'm going to make that one PoE V plus. What I'm trying to do at this point is I'm not trying to make it pretty, I'm just trying to make it work logically. And then I can rationalize this layout. This is kind of all over the place at the moment. So what we can see is we've got PoE V plus, this net coming in here into this jumper is the same as this net down here going into this regulator module. What I might do is move this up to the top, move these lower down, maybe even put them on either side. Don't know. Anyway, I'm going to rethink that when I move this onto the other sheet. But what I want to end up with here is 3 different ways the power can come in. It can either come in as 48 volt PoE into this regulator module, which is the PoE 802.3 AF module, and then the output of that goes into this voltage regulator. Or it can come in through this power jack straight into the voltage regulator. Or it can come in and bypass the PoE module if you wanted to just inject like 12 volts down the wire if you put these jumpers in place. So there are really 3 powering options there. And that schematic layout is not great, but technically I think that is correct. And that means I can now, in fact what I'm going to do is let's add the NC, the non-connected links onto those extra inputs on that module, and come down here and let's just get rid of this. Don't need this anymore, I'm pretty sure. One final thought before I do it. Am I going to delete it? I think I'm going to delete it. So let's delete that group, come back to here, and I'm also going to change these diodes to be, I've got one in, it's the same footprint, and I'm not really as scientific as I should be about this. I tend to use SS56s when there's the possibility of a bit more current, just because the Schottky diodes are more, they have a lower forward voltage drop than regular silicon rectifier diodes, but I could just use 1N4004s in there instead. That looks okay. All right. Now, as a let's come back to the, where is it? I'm going to come back to the board layout just temporarily. I've got a whole lot of stuff over here that's just hanging out, doing its thing. Let's just pick up that big bunch of parts and stick it over here somewhere. I'm probably a bit foolish doing that. No, I shouldn't do that just yet. What I should do is get this, let's rip that up. Make it easier to see what's going on. I need to move this temperature sensor further out of the way. Move. Ideally, I want the temperature sensor over near the voltage regulator because I want it to be, it's not for measuring the environmental temperature, it's for measuring the temperature that this device is running at. So let's stick that, I don't know, down here somewhere. There will do. Because I want to detect things like if this is running hot, like the voltage regulator is typically where the heat is going to be coming from, I want to know about it. I want to be able to characterize it. So let's give this another push over to Fusion. What's everybody talking about while I'm just rambling? Yes. Yeah, okay, so there has been some interesting discussion. So you're going to need, oh, okay. Austin says you're going to need VB1 and 2 with that Ethernet jack. All right, cool. I will check your schematic and add that back in again. Now, what else do we have? Cable Tie asked a very good question, which is why separate jacks, J3 and 4 for the jumpers? And the correct answer was from Stephen, which is to avoid accidentally jumpering a short between them. Now this raises an interesting point. Stephen also said, stick 2 sensors on the board, one under the Pi, one by the power. Yeah, that's actually a good idea. So this raises another thing. Now, this is something else that I would appreciate feedback on. So I'm going to go back to the overhead camera. Oh, it has push diffusion. We'll get back to that. Back to the board. Now, those 2 jumpers that the Cable Tie was just asking about, it's these jumpers right here. That one and that one. They are right angle 1x2 jumpers, and they are visible externally through that little thing here. I really don't like this. This is an ugly, nasty solution. But what it does is it exposes these 2 pin headers through this slot in the enclosure, and then what I can do is put jumpers on them in order to bypass the onboard PoE regulator and just feed something like 12 volts directly down the wire. That is nasty. What would be ideal would be auto sensing on the board. So if you feed something like 12 volts through it, it passes through to the regulator, but as soon as the voltage that you're passing through gets above a certain threshold, like say 16 volts, it disconnects and will not pass the power directly to the regulator. Instead, it goes to the PoE module. So I could probably do that using something basically I need a threshold trigger. I could use maybe an op amp or something and set a threshold where it switches between those 2 destinations for the power. And then these jumpers could go away and you could put 12 volts down the wire and it would work, or you could plug it into a proper PoE Ethernet switch and it would still work. That would be nice. And we could even have it detect, like the Pi on here could use one of its GPIOs and detect the state of the power source and be able to report back, hey, I'm running on 802.3 AF, or hey, I'm running on 12 volt PoE or whatever. So that could be useful. But without that, as a simple solution, I just put these jumpers on the board, which is kind of awkward because they're right in here. Once this is all screwed together, it's awkward putting the jumpers on, and it's even more awkward getting them off. You've got to use like needle nose pliers or something to pull them out. Or get your fingernails in there and get them onto the edge of the jumpers to flick them out. So I don't really like this solution. The thing is, I've thought about putting a switch in, so you switch between the modes, whether you want 802.3 AF or DIY PoE. But the problem is that flicking a switch is too easy, and it would be very easy to have the switch in the wrong position and plug it into an Ethernet switch and have it pass that 48 volts directly to the input of this voltage regulator, which would kind of not work. So I don't have a great solution to it. I figure that having jumpers on here, that you have to make the decision to put the jumpers in place, and it's actually slightly awkward, kind of protects you, because it means that you're not going to just flick the switch, have it in the wrong place, plug it into an Ethernet thing, and have bad stuff happen. You have to consciously put those on because you know you want the power over Ethernet bypass. But I would appreciate thoughts on that. If someone has ideas about the best way to handle that, that would be really cool. Yes. Oh, Cable Tie says, do the auto switch. Yeah. Yeah, and Stephen says you would have a very unhappy 7805 with 48 volts in. Yes, exactly. Right. Now, let's go back to... Where am I? Going back to here. And I'm going to make some more to-do list notes just based on those comments. So let's see. Auto switch PoE destination. I'll put it that way. And I'll put a question mark about it because I don't know if I will actually do it. Now this also comes down to this whole iteration approach. Jordan makes a very good point, which is those pins also expose 48 volts when using AF. They do, yes, they do. Yeah, I hadn't even thought about that. You're absolutely right. So we've got 48 volts hanging out of the side of the access point on exposed pin headers. That is suboptimal. So auto switch PoE destination. What I could do, I suppose I don't have to populate it. What I might do is I will try to figure out an auto switch circuit to put in there. The thing is that this is, once again, it's another unknown, and I don't know if I want to take this unknown on in this iteration or whether that's for a future iteration. And the simple thing is to just leave it as I've got it with the pin headers, because it works with those limitations that I've just been discussing. I know that it works. It's one less risk in this cycle of the iteration. And yeah, I don't know. I'm going backwards and forwards in my head right now about making the decision. All right, I am going to leave that in the to-do list. Auto switch the power over Ethernet destination. Yeah, I'm thinking about ways to do that with a mini relay. I think that might be the best way. What I could do is I could put a, I can replace those jumpers with the normally, oh, I'm going to have to think this through, but I was thinking of replacing them with the normally closed connections of the, yeah, there's a timing problem. All right, I know this is bad, but I'm going to say it anyway. The normally closed connections of a double pole, double throw relay as those jumpers, which means that by default, the onboard PoE regulator is bypassed and power can go straight through. Then have like a threshold switch that if the input voltage is above, say, 16 volts or 18 volts or some reasonable limit, it will fire the relay and disconnect the direct connection, and then the power has to go only through the PoE module. Now that is kind of a backwards way of doing it. It probably should be the other way, so that if it fires the relay to bypass the PoE module, if the voltage is below a certain threshold. That is kind of the logical way to do it. All right. Richard says, having worked telecoms for several years, I can say 48 volts is not pleasant, but not the worst. Can't say I've ever licked it. No, hell no, you would not want to lick that. And Cable Tie says you could option both solutions to the circuit. Yeah, that's right. Do a couple of DNFs, do not fits. Yep. Or DNPs, I normally say do not place. So Jordan says, doesn't AF handshake before sending full voltage? It handshakes before sending full power, I believe. not necessarily full voltage. So, or maybe it is. But yeah, I'm going to have to think about that one a bit. I would like to have some kind of an auto switch circuit on there. Now, what was the other thing? There were two things I wanted to add to the to-do list. There was the auto switch PoE destination, and there was some other comment. Oh, that's right. Yes, the two sensors. Second temp sensor for Pi. I'll add that as a question mark as well. So I could put two temperature sensors on the board. The thing is that the temperature sensor for the Pi wouldn't be actually like right at the Pi. It will be significantly air gapped from it. So I have, unless it was like a sensor on a flying lead that was attached to the Pi, I think that would have very limited use, limited benefit. But anyway, let's, and Cable Tie says the handshaking is all internal to the PoE module and chip though. Oh, and also points out that the Pi has its own temperature sensor. Yes, okay, good point. Let's remove that. Second temperature sensor for Pi is coming off the to-do list. Woohoo! That's the best thing, when you add things to the to-do list and then you delete them from the to-do list because you didn't even have to do them. Let's go back to F360. Come on, context switch. Here we go. Refresh. And yeah, that's right. Cable Tie was saying you could option both solutions into the circuit. Yeah, I think I will try to come up with a way of doing the auto selection. I think doing it with, I know it's kind of old school, but I think doing it with relays. In fact, I have some relays here that would do the job just nicely. These ones, pin's a little bit bent on that. I recently bought a bag of these for a totally unrelated project, and I happen to have them sitting right here. Got a little bag of relays. So these are double pole, double throw relays, 2 amp rated, 2 amps at, what does it say? 2 amps at 24 volts DC, but it would handle 48, no problem. Yes, so these little relays could be the solution. And I know it's not solid state, but sometimes just having a direct connection is like a mechanical switch is the best way to do things rather than using MOSFETs or something. Yeah, Stephen says 2 amps is excessive for the 48 volt side of PoE. Yep. So it should be fine. All right, you can see the little temperature sensor there hanging off in space. And there are all the parts for the Ethernet interface, and we've got our Pi in place. It's sitting floating above the board because it'll be on headers. We've got our Ethernet socket, which is hanging around underneath. Oh, I know what I need to add to the to-do list. What I need to do is, and I'm not going to actually do this now because I want to verify and make sure it's right before I do it, which is fix location of mounting holes and fix location of mode button. Now, oh, I should explain this mode button too. So this thing here, hang on, it would really help if I switch back to here. So this thing here, this is a push button which protrudes through the external, oh, and I've got to assign a pin. Okay, that's another thing to go on the to-do list. But anyway, this button protrudes through the case, and what I wanted to do was have that for things like factory reset or putting it into pairing mode or whatever. So I'm going to say assign IO pin to mode button. And the other things I added on here were fixed location of mounting holes and fixed location of mode button, which is just slightly offset to the side. So yeah, I want to be able to do things like be able to hold in the mode button while powering it up in order to put it into like a factory reset mode or an adoption mode, so that it can then be adopted into the management system. So that's just the reason for having that that button right there, which sticks out through the case. Okay. Now, where am I? Yes. Oh, Richard says, relays are more complex and occupy more board space than a switch on the coaxial input jack. Okay, the thing is that that doesn't entirely solve the problem. Yes, there is a switch on that jack, and what I could do is use the switch on the jack to isolate PoE, but the problem is supporting two different, that's not the problem. The problem is supporting two different types of PoE. What I want to be able to support is like proper official standards compliant PoE, not the most recent high power standard like the AT or whatever it is standard. I just want to support at least 802.3 AF, which is the older PoE standard. It's pretty much ubiquitous. Any PoE gear, that's what it supports at least. And that supplies a nominal 48 volts down the wire. Or being able to just DIY your own power over Ethernet, which is a pretty common thing to do, and I've done it many times, where you take the same pairs and you just put 12 volts, or whatever you want, but typically 12 volts, sometimes 24 volts, straight down the wire with no negotiation. There's no PoE module involved at the other end. It is just you are using the extra pairs of the Ethernet cable to pass voltage down the wire, and that is then being pulled out at the other end and run into a voltage regulator. So what we are seeing here is with these jumpers, the idea is we've got power here coming out of the Ethernet socket. I've got to fix up this footprint, and I've got to check the pinout based on what Austin has now sent me. So we take the extra pairs that are coming out of the Ethernet socket, and we put jumpers in place, and just whatever comes down the cable gets fed into the voltage regulator right here. So we're not doing any other processing on it at all. That's the only reason for doing that. So having the switch on that barrel jack doesn't help solve that problem, unfortunately. It's a different problem. Right. I am going to wrap it up. Will it speak in Mandarin when it boots? Maybe. I should make it do that. I could, yeah, I could have it boot up and go, ni hao ma. Ooh, interesting. So Richard says, I seem to remember an IC designed for this, Maxim. My old memory may fail me here. Yeah. Right. Oh, Andrew says, I question its value for the complexity it adds. If a user wants to manually PoE, then they take on responsibility. Yeah. The thing is that I do it a lot myself as well. So I'm kind of making it easier for myself to do this dodgy DIY PoE type approach. What? It is 12:36. How has somebody not been shouting at me to get off the live stream? What's going on? No wonder I'm tired and hungry. Ah, I need to get off this. Cable Tie says lunchtime. Yes. So, anyway, hopefully hopefully there's been a little bit of progress on this today. It's not a lot of progress in terms of the actual design, but talking through it really does help to clarify this in my own head in terms of what it is that I'm trying to do. And yeah. Oh, Stephen says needs 2x470 ohm resistors and a 100 nanofarad 100 volt cap. Yeah, so that would be for setting up the signaling on the line, I think. On Cable Tie says, this is in relation to Will It Speak Mandarin. Cable Tie says, that's on my mind because I've just been fighting with the Xiaomi Zigbee hub and that's what it does. Okay, so you start up the Zigbee hub and it speaks to you in Mandarin. That's interesting. Okay. I really could keep going here, but I need to stop. My jaw is starting to hurt again. I'm still not 100% healed from that from the wisdom teeth extraction. I'm getting there, but there's still inflammation in my jaw, particularly on the left side. That's it hasn't gone away yet, and I'm definitely feeling it now that I've been talking for 2 hours and 38 minutes, pretty much non-stop. I need to take a break. So thank you everybody for coming along, and yeah, I'm really excited about this project. I like the way going up against Unify and building our own stuff and having it all open source and flexible and adding features into it that I wish Unify access points had, like also being a Zigbee gateway and all those sorts of things. We can do cool things with it. Having devices in strategic locations around the house that we have control over means we can do fun things. So thank you very much, and Tim just says, would it be mesh based? It could, but my plan is not initially, at least. Minimum viable product, minimal viable project is no, I won't have any mesh in it. But thanks. I am going to go and rest my jaw. Thanks for coming along, and I will talk to you all really soon. Bye. I hit myself in the glasses. Bye.